Thanks everyone for coming for the event, and thanks to DSCI for generously supporting us and giving us an opportunity to present, right? And yeah, maybe I'll just do a very quick intro about what PQ Station is, what we've been doing, and then I'll dive straight into the agenda for our session today. So yeah, so basically we've been working on PQC for the past I'd say more than 8 years, since 2017, specifically focusing on how do you implement PQC in real world systems. We've been studying this problem since 2017, trying to implement PQC on a variety of different platforms, right from your Intel AMD CPUs to GPUs to even the smallest of microcontrollers. We have been very active in the cybersecurity research space, publishing on PQC implementations, PQC security on real world implementations. And we are working on several translational grants out of the university. So we are basically a spin-off from Nanyang Technological University, Singapore, which is one of the largest universities in Singapore. We are right now working on several translational grants with multiple industrial partners, which includes organizations like OCBC, which includes Standard Chartered Bank, GovTech Singapore, HTX, and so on. These are different government agencies taking care of IT systems there. Mainly focusing on enterprise-grade quantum-safe migration. As you all know, regulators around the world are actually pushing organizations to become quantum safe, and definitely as a topic it's picked up very much over the last a year, and for the last 6 months we're seeing more and more regulations, guidelines, advisories coming from all parts of the world, and I think this is the right time to start focusing on this topic and bringing this to enterprises. And while we've been working on a lot of product development and also a lot of research, we've also been closely working with the ecosystem. In Singapore, the Cybersecurity Agency has released a quantum safe migration handbook. This is a practical guide for security practitioners that details the different steps on what needs to be done in order for you to go on this journey of quantum safe migration. And we specifically focused on the preparation phases, which is your cryptographic inventory, risk assessment, how that has to be done, and what you can do, what you cannot do, and can you already get started? Should you wait for vendor provided tools, or can you already get started with what you already have? These are some of the finer points that we have discussed as part of the migration handbook. And we also co-authored a white paper with MasterCard on quantum threat for the financial sector, going into different use cases for BFSI. In India, we've also signed an MOU with the Amravati Quantum Valley, where we're basically trying to set up a quantum security testbed. And it's also part of the quantum safe migration sandbox that we are building right now, where the idea is, instead of organizations directly starting activities on quantum security on their own infrastructure, can they use some sort of a playground or a sandbox environment where they can actually try out things, practice, fail, and then go to production. So we are seeing this as an increasing need amongst organizations, not just in Singapore, even in India. We've had multiple discussions with DSCI where when they are engaging with regulators, the feedback that they get is that we are yet not at a stage where we're ready to touch our production grade infra already. So can we have some sort of an infra where we can actually sort of play around, understand what quantum safe migration is about before going to production? So that was the whole point of the quantum security testbed, or the migration sandbox. And the migration sandbox is built in such a way that it mirrors some of your enterprise applications, enterprise environments, and you can basically try out different tools. Either you build your own tools for quantum safe migration, or you can basically try out any other vendor provided tools and carry out activities there. So that's the whole point of this. And maybe a slide on how we actually see the whole quantum safe migration problem, right? So we consider organizations to be in what we call as the state of cryptographic rigidity. And what I mean by cryptographic rigidity is that there is, zero is probably a strong word here, but basically there is very little governance and ownership on cryptography itself. who owns cryptography, who needs to drive any cryptographic upgrades in my systems? Is there a governance process in place? And in fact, is there even cryptographic requirements in place? For example, if we talk to CISO teams, they talk about PCI DSS compliance, HIPAA, maybe GDPR, DPDP, so many things are there. But then there are no specific cryptographic requirements that goes into the details of what key exchange algorithm has to be used, what certificates has to be used. For example, for data in transit over public networks, what algorithm should I rely on? For data in transit over my internal networks, what should I rely on? So there is no such fine-grained cryptographic requirements that's specified to a certain degree. And because of that, what happens is that it's very hard for us to set goalposts. Where you are today, where you have to be in the future, it's not. If that is not clearly defined, how can you claim whether you're quantum safe or classical safe or whatever, right? So we think that organizations are in the state of cryptographic rigidity, where there is no management and governance of cryptography as a technology within your organization. And we want to move organizations towards cryptographic agility. And what I mean by cryptographic agility is you have continued management and governance of cryptography. So if that's too technical, maybe I can just give you a scenario. Think of it like this, right? So let's say tomorrow there is a news. So, or not tomorrow, maybe in a couple of years, let's say there is news that MLChem is broken. And let's say in your organization, you have got your management buy-in, you have spent 2 years implementing MLChem everywhere and anywhere. And one fine day MLChem is broken. And it is possible because cryptographic attacks can happen anytime. All it takes is one intelligent researcher to come up with a new, maybe Shor++ algorithm that can break MLChem. So it's very much possible. Now, when that news comes out, how quickly can you roll back support for MLChem across all of your systems, applications, and infrastructure? Do you even have a process in place to do that? Forget about technology. Do you even have a process to control cryptography in all of your different systems? Unfortunately, it's not there today. And that's why we believe that quantum safe migration is about setting a process of cryptographic management inside your enterprise. And that's how we can actually move from the state of rigidity towards cryptographic agility. So don't think of quantum safe migration as a one-time process, but it's a process that you will have to probably do again and again and again. So you're constantly above or constantly staying ahead of your quantum threats, because quantum threat landscape will evolve. Algorithms might be broken in the future. I'm not claiming it will, but at least algorithms, it's very much possible that they'll be weakened over time. And let's say if you want to do another cryptographic upgrade across your infrastructure, you should not spend the same amount of time, effort, money in order to do that. You should be able to do it fairly quickly. And that's why we are talking about quantum safe migration as a continuous process. You're constantly staying ahead of this threat. And the reason why we're talking about it right now is because of advancements in the quantum computing space that we are seeing more and more. Why? Because there's a lot of money being pumped into making quantum computers faster. And that's why it's a new threat. We should have done cryptographic management years ago. Even when we started incorporating any sort of, even when we started to incorporate any sort of cryptography in our infrastructure, we should have understood how to manage it. But at that point in time, it was not needed because whatever cryptography I'm using is secure. RSA is secure, ECC is secure, AES is secure, so I didn't really have to worry about it. As long as it is HTTPS, as long as it's using AES 128 or 256, I'm good. But right now things are changing, and that's why there's a need to understand how can I do cryptographic management as a continuous process in my organization, and that's why we're having this conversation in the first place. And we believe that if you're able to set up a certain process for cryptographic management in your organization today, then quantum safe migration will become a very much easier problem to solve. Right now it's taking many, many years. It's a very manual process. There's no tools to do that. There's no process to do that. And hence it feels like we need to spend 5 years, 10 years to actually do quantum safe migration. But it need not be like that. If you know where your cryptography lies, how it's being used, and you have the power to configure cryptography in your systems. The moment you have that, then I think you are in a much better place, and all your migration timelines can basically shrink considerably. So that's why we are talking about the movement towards cryptographic rigidity to agility as a long-term solution for any cryptographic upgrades. Right now we're discussing quantum. There might be more powerful computers than quantum in the future that might even break MLChem or MLDSA or whatever, right? So how do you constantly stay updated? And we believe that cryptographic agility is the long-term solution, and that's the process that we need to put in place in our organization. And inventory, risk analysis, everything is part of that process, and we are basically trying to ensure how can we do it continuously in a manner that you're not doing it manually, you're not spending so much effort, so much specialized resources. Yeah. And at the center of that process that we're trying to put in place is the cryptographic management platform, which is QVision, which basically allows you to understand what cryptography is used where, contextualize it, and also with the help of actuators, configure or control what cryptography can be used in your systems. Obviously, it depends on a variety of different factors based on vendor lock-in, vendor support, and so on and so forth. But the whole idea is how much control you have cryptography with you. As a cybersecurity team, as a CISO team, how much control do you have? And the more control you have, the better you are placed in order to deal with the whole quantum safe or quantum threat. And the QVision cryptographic management platform basically allows you to automate processes like risk assessment from a cryptographic standpoint, discovery, executing migration. Why I'm saying executing migration here? Because your vendors might say, I have PQC support. Now, but do you have the courage and the clarity that if I turn on the PQC switch in my system, will it bring down my system or not? And that's a question a lot of organizations grapple with, right? I have a new feature, a new security feature. Now, if I turn it on and if it's in my data path, what overheads will I incur? Do I have the dependencies mapped out in such a way that if I turn on PQC here, it's not going to bring any other service down and it's not going to result in business losses, right? So business continuity is very important, and that's why even if PQC support is there in your system, how do you operationalize PQC support? That's what I talk about. That's what I'm referring to as migration execution. And then we're talking about testing and validating, understanding whether your overheads are good, like your overheads are bearable, understanding whether you have implemented PQC in the right manner, all of these things, and continuous monitoring. How do you constantly stay ahead of the threat? So the true North Star for cryptographic agility is you hear a news about a break of a cryptographic algorithm, you exactly know which teams you need to talk to, which systems you need to touch, and what is the timeline that I need, what is the process I need to actually do the rollback or do the upgrade or downgrade, whatever you think about it. That is the true state of cryptographic agility, and I feel that if as organizations we reach that point, I think we are very well placed to counter a quantum threat. Then it's all about just engaging with vendor and ensuring that they have PQC support in place and you know exactly how to operationalize PQC in your environment. Right? So this is the big story that we're trying to basically build. Again, it's not a point solution, it's a process that we're trying to put in place, but you need some sort of technology to automate this process and to make it more efficient, quicker, and faster. So that's the story. Now, yeah, and these are some of the organizations that we're working with. OCBC, BSSN is the National Cyber and Crypto Agency of Indonesia. We're also working with GovTech Singapore. GovTech manages over 120 plus IT systems of several government agencies in Singapore, and we also closely collaborate with CSA. CSA is the regulator for cybersecurity for critical infrastructure sector, and we are closely working with them to set up a quantum safe policy for critical infrastructure in Singapore. And there are plans to actually roll out a policy soon, and we are closely working with them. And obviously, we're also having our strategic partnerships with cybersecurity providers. And yeah, now maybe I'll come to the session agenda. So essentially, we're covering 3 points here. First is the quantum safe migration sandbox, why it is built, what it is, and how it works. It is a work in progress. It's not complete, but we are seeing growing demand for this because organizations don't want to touch their infra readily, so they want a playground to play, and that's what it is. Then we're going to talk about a cryptographic management process, and we're not going to cover the end-to-end spectrum, but we will mainly focus on the planning phase. specifically on how do you set cryptographic requirements for your infrastructure, and how do you frame it into a cryptographic policy, and after you do cryptographic inventory, how do you actually check for compliance with the cryptographic policy. So you set the goalpost, and then you're basically checking if your CBOM is compliant with the goalpost. So that's the process. That's what we plan to sort of briefly walk through in the demo session that Arav, a CTO of PQ Station, will be presenting. And as part of that, we'll also be demonstrating QVision in action on the Sandbox environment. That's also something that we plan to cover. So now onto the migration sandbox. So basically the idea is to mirror an enterprise topology as much as possible. And we want to sort of include different scenarios and use cases containing legacy protocols, legacy algorithms, different types of data flows, different systems talking to each other, introducing all sorts of dependencies, and giving you a playground to play with so that you can then practice quantum safe migration on that environment before you actually start touching your production grade systems. And yeah, big disclaimer, it's still a work in progress, but we are sort of building towards that, and Arav will sort of walk you through that. And yeah, I think I've sort of covered all these points here. And we'll also talk about cryptographic management process. And we're specifically wanting to focus on the planning phase of it. And we want to split it into 3 phases. So first is you want to define a protection profile for your organization. As I mentioned earlier, there are no clearly defined cryptographic requirements. And that's what we're sort of trying to put in place. Can we define a protection profile or a goalpost, what good looks like for an organization today? That good will keep changing over time. But at least are we able to define what that good looks like, considering different factors? And then we want to do a service assessment. And so when I say service assessment, where this is actually coming from is that a lot of organizations think about migrating entire infrastructures to quantum safe. And that big bang migration is very hard to do. And probably it's not the right way to think about it. The right way to think about it is that you adopt a divide and conquer strategy. Let's say if you're a bank, or if you're a stockbroking company, you're offering services to your customers. And think about how that service can be quantum safe. So instead of thinking about how my entire infrastructure is quantum safe, how can I think about how a specific service that I offer to my customer is quantum safe? Then what you do is you're scoping down the problem and making it more precise. So if this particular service is supposed to be quantum safe, then I can basically define a protection profile. And then I can then understand what are the different infrastructure components that are coming together to deliver that particular service. And then you can start going deeper and deeper and understanding that, okay, if I want to make this particular service quantum safe, these are the infrastructure components that I have to touch. And I need to incorporate PQC in these infrastructure components, and you sort of go down the rabbit hole. So we are trying to scope that problem into a service assessment. And once you do that, then you can basically start doing your discovery. And once you do your discovery, then you can start analyze the output of the discovery process against the protection profile you're defining. So that's the sort of overall flow that we're trying to define here. And maybe I'll just hand it over to Arav. Arav can sort of walk through the demo flow. Thanks. Thank you.
Thank you, Prasanna. Just give me a quick technical break. I'll just set up the demo and we'll be back shortly. Yeah, thank you for the break. I think we're ready now. And just catching up from where Prasanna left, I think 3 main ideas that we wanted to discuss in this demo is basically setting up a goalpost, right? A lot of organizations, they are getting into cryptographic inventory, but what do you inventory, right? There's a question. And how do you answer that question is by setting up some certain sort of goalpost for your organization, that I want this level of security for these connections, and for these data traveling in these exposures, they need to be protected using certain algorithms. So I will talk a little bit about that protection profile. I will talk about service assessment, which is taking up Girishi's idea of connecting your business logic with crypto services. How you have a high-level services such as your mobile banking, and how do you connect it with your crypto surface? because mobile banking is a terminology that your CISOs understand, and you want to bring that down to your TLS versions, your cipher suites, and that is something I will discuss in phase 2. Phase 3 is about how do you start discovering. You don't need to install sensors and agents in every system out there, right? You can start with some alternative methods, and that's again something Girish also touched upon, that there are hundreds of ways of discovering cryptographic information, right? Our approach is that why don't you start with the simplest methods? And we have our testbed running on AWS, and there are some AWS specific solutions which obviously translate into other cloud platforms, as well as on-prem settings, which are your alternative ways of doing discovery, which is processing logs and filling up your inventory based on that. So I'll just start on that. Right. So the part 1 is, of course, about setting up the goalpost, right? That before you start doing an inventory, before you start assessing, doing an inventory of every key, every SSH key, every certificate out there, why don't you start with what is it that you want to achieve with this cryptographic inventory, right? Whether you want to move to post-quantum, whether you want to ensure that you're classically safe. It may not be a priority that you want to shift to post-quantum, but why don't we start with setting up a framework to ensure that at least we are classically safe, right? And that's something I will just cover. There's an idea that we are working with, at least starting with 2 parameters. 2 parameters being that where the data is flowing, whether the data is flowing over your public channels, whether the data is flowing internally, whether the data goes from internal to external, different egress-ingress flows, and what kind of data sensitivity in those flows is being seen, right? That defines what kind of protection profile you set, because you can't have a single profile for all the data and all the connections, because certain connections are latency sensitive, certain connections are just logs and static content, which may not need your PQC level of protection. So the first step is basically setting up a protection profile, right? And I can quickly show it on the dashboard, which is, yeah. Right? So what we have defined here is in the tool basically 3 types of policy protection profiles. Another point that I would like to mention is that we are starting with, I apologize about the resolution, but I think, first part that we are starting with is TLS. I think that's the most practical and a practitioner's approach, that not look at every protocol out there, every custom protocol you're looking at there. I think most of your data is actually flowing over TLS, and a lot of your security is taken care of once you ensure that your TLS is working. But what's complicated about configuring TLS is TLS involves a lot of parts. I think one of the earlier presentations covered, there's an authentication part, there's a confidentiality part, and non-repudiation part, right? And just to ensure these 3 properties, it takes up a lot of infrastructure, right? You have your signing involved, your PKI stack, your entire PKI stack, and then your libraries and so many things. So just ensuring that your TLS is well profiled in your infrastructure, I think that's a very good starting step. And it's a simple way to get started as well. So what we did is basically, when do you apply these protection profiles, right? As I mentioned, it depends on the kind of data that's flowing and the kind of direction that data is flowing over. So we have marked the data in 3 tiers, your T1, your T2, and T3, which are increasing level of sensitivity. And as you can see for the last column, for T3, when the traffic, and by T3 as an example, it could be your secrets, and organizational secrets, or PII, and sensitive documents that are going over the data flows. And it doesn't matter which flow it's flowing on, right? You want the absolute most security for those kind of data. And this is where we have 3 different profiles, and each of them allows us to set up different levels of different settings for TLS. Maybe, for an example, baseline, let's say, has no particular allowed cipher suite. You can have any cipher suite because maybe that's what the organization wants. For an enhanced version, you have a restricted version of cipher suites, which are at least AEAD protected, right? And you have certain levels of key exchange curves. And for advanced, you're much more strict. You only want TLS 1.3 and you only want cipher switches that provide you AED. And only these key exchange curves, key exchange curves. And of course, as a preferred key exchange curves, because right now there's not a lot of operationalization of MLChem or post-quantum key exchange curves. So at least that's something you can set as preferred key exchange curves to set up a goalpost. But you don't want to fail all your compliance checks right now. So we start with classical key exchange curves, but we restrict the set to only the allowed key exchange curves. Right? Let me go back. So I think this covers more or less the phase 1. We have some certain sort of a goalpost, and let me now go to phase 2. Phase 2 is basically, I think this is the most manual step still, where you actually have to involve the humans. I think in our work so far, in all our case studies so far, we realize that not everything can be automated. You can't just trigger a button and suddenly all your problems are solved, right? You have to involve the humans that actually manage those services, because there's a lot of human knowledge involved in these phases in this service assessment. So what we do is what we did essentially with a partner was basically we sat down with the payment architects, we sat down with the security team, we started to understand what kind of data is flowing in which direction, and start drawing up diagrams. Because I think once you have that clarity of how your infrastructure is set up and what kind of data is flowing on what flows, it's a lot easier to figure out what kind of protection profiles you want to set up for each data flow. Right? And once you've done with basically this services assessment is when you, actually I can now jump in quickly to the demo, and I actually want to show some alternative ways too. I mean, obviously there is a manual component to it, but we also try to see if we can leverage on, let's say, existing CMDBs, existing configurations, to at least get some idea of what kind of services and their components we have in an environment. Yeah, this is the part where we look at different ways of getting the information that could be taken manually as well. Another problem with manual effort is that there is human factor involved, so they're obviously relying on a human's memory and their ability to remember what kind of TLS version they had configured in certain settings. Obviously, it's not a very reliable source of knowledge, and it gets outdated very fast. So you need some automated ways to do discovery and keep your inventory updated. And yeah, I would start with, actually what we did with a partner was, this is a fast payment infrastructure. I mean, I want to give you a very high level picture of how complicated it keeps on going. Once you start mapping the data flows, what the kind of data that's being carried on each interface, and the kind of components that are involved, it becomes quite big, and it's a lot to cover for this demo. So what we have taken down is basically a very simple architecture, which I can just show. So I want to start with a simple user journey, right? A user for backend for frontend is very common for any actually 3-tier applications, which could be your mobile banking application, where a customer or an internet banking application where a user is trying to access authenticate to the backend and make a payment, right? But before you even hit the switch, the actual payment backend, the core banking services, there is something called backend for frontend. And how the journey flows is that a user basically talks to, there are obviously paths in between where you have the CDN involved and you have more WAFs. I think we already talked a lot about that, but just to keep it simple, the user directly talks to the load balancer, and the load balancer basically is talking to two Nginx. They're running on 2 different VMs, which acts as the web servers, right? And which is also the TLS termination point for the customer. And after that, there's another mutual TLS setup between your edge boundary to your actual core application, which is a Django application running in another instance. And once you have that, you have a storage tier, which is where we are running a MongoDB database in another VM. And again, these are all pathways where TLS is terminated at one hop and then carried forward. And that is one backend for front-end service. And then another service that we are also depicting in this diagram is a VPN gateway. Users talk to a VPN gateway to access the internal resources of the organization. And that's another service that could be checked for IPsec connectivity and the kind of algorithms that are being used there. Another one I wanted to show, just to give you ideas of different kinds of protocols that could be there, is the Bastion server. A Bastion server is basically where the user SSHs into the Bastion service inside the organization to actually SSH into another system. And in this particular case, the user is SSHing into the Bastion server, and then through that SSHing into the database. Why this complicated flow is there? Because you'll see there are multiple data flows. There are multiple data flows, and there are different ways of accessing the same data. There is one way of accessing MongoDB where we keep a lot of our critical information is through this entire 3-tier infrastructure. Another way is going over SSH. So the same data could actually be looked at from different angles. And yeah, I think once the service is set up, basically you want to move to discovery. And we are building this platform. Again, there are so many ways of doing crypto inventory, especially because there are so many ways to deploy an infrastructure. You have an on-prem, you have a cloud infrastructure, you have hybrid infrastructure, and then you have so many variations in the kind of vendors that people are using, and so many different ways of how they implement security. Some organizations use a vault instead of an HSM for their mid-level secrets, and they use HSM only for their top tier secrets. Then you need to have a discovery process for the vault and the HSM. Then you need to have a correlation whether an HSM is being used or is it in a vault. So that is why I think we really have to work on a kind of discovery we do and the kind of integrations we build. And that is something that we're doing with QVision. I think now basically I can show some alternative ways of how we are looking at this cryptographic inventory, right? So I'll start with basically actually a quick demo on how we were initially doing inventory, right? What we started with was, let's just scan all the assets or all the infrastructure that we have in our VPC. And what we ended up with was basically an unclassified inventory, which had actually, if I remove the filters, which has over 1,000 touch points, 1,000 endpoints, which contains a lot of public networks, and I can just, which in fact also contained a lot of internal touch points. These are all TLS based. Then there are SSH, IPsec, and quick touch points. Then they have their own certificates and primitives. I think it was not an easy way to look at this, because you don't know now what to prioritize. We wanted to add a layer of prioritization, which can only be added when you combine the crypto surface with the business layer. And which is where we have this hierarchy where we start with a service. And in the previous slide, I showed you 3 services. We talked about the VPN gateway, the Bastion, and the actual backend for front end, right? And I basically want to start with that. And let me just quickly import a JSON file. This could be something that you work internally with the business people to get the services onboarded. And it's a simple JSON file that I simply use to import the services, right? But this is just the top layer, just to give more context to the rest of the inventory process. Next, I basically start with the components. What are the servers and HSMs and the infrastructure components that are supporting this service? And for this, again, there are multiple ways, but the testbed that I talked about, basically this is set up on AWS. There's an entire VPC, and these are all different EC2 instances. And this load balancer is actually a AWS network load balancer. And they're all configured with different TLS policies so that we can see the inventory process. Yeah. So the simplest method that we started with, rather than enumerating through all the components in a VPC, what we relied on was an AWS config file. Again, I know it's not very readable, but this is just to give you an idea of what a configuration file can look like. It basically mentions all the instances that I just described to you, but in a configuration format. It talks about its actual location, the tags, and the tags are very important here, right? The tags are basically what an organization sets, that this particular EC2 instance actually sits in my DMZ. This particular instance is actually handling a certain level of data sensitivity, which will actually help us apply a protection profile. So once you get this configuration, and this configuration for an AWS VPC is actually quite easy. I just had to run one command, and I get this configuration file for my system. And what we do now is simply go to a scan, and I want to upload an AWS configuration file. I will quickly upload this AWS config snapshot. I will enable manually. There is a way to automatically attribute each of these components to the service, but for the sake of the demo, I'm going to try to do it manually. So it immediately creates these components, the components that I just described to you, the Nginx web servers, the MongoDB, and the Django app, right? All these components are, as you can see, in my inventory, but yet they're right now not associated with any of the services. So what I can quickly do is attribute, associate these service. For admin access, I'm basically talking about my Bastion server. For my VPN, I'm actually talking about, from admin access, I'm actually talking about the DB as well. So let me just set up the prod Mongo, and then let me set up the VPN service as well. And let me then set up with the mobile banking. So I can set up my Nginx servers, my mobile banking app, my NLB, and my database. So you'll see this database is actually a shared infrastructure between two services, which again gets highlighted once you get down to the service level specifics. Next is basically, once I have onboarded the components, right? Let me just show you the components. Once you've onboarded the components through our AWS configuration files, you're still not sure what these components are actually running. You have an Nginx server on your in your inventory, but what does this Nginx server actually run, right? Is it running a TLS server or a quick server, or is it actually just not even a termination point? For that, we're basically now gonna go to touch points. As you can see right now, we have 0 touch points associated with this service. What I'll quickly do is basically onboard the touch points as well. Again, there are multiple ways. For cloud, what we're looking at is the VPC flow logs. For your on-premise infrastructure, you could use something like Webflow traffic, which again gives you the kind of network traffic that's flowing in your organization and allows you to map out touch points for that service. So let me just quickly go to scans and upload VPC flow logs, which basically creates a connection graph of all the components that are there in my VPC. So I can just quickly select VPC flow logs, and I could manually again associate each touch point to its component, but I want to quicken the demo, and let me just create that. And what it actually does, actually, one second. So just give me 1 second. So let me go back to my mobile for banking front end, and let me go to my mobile banking app, and then as before, let me just upload my touch points as well, which I do through the VPC flow logs. Right. So I have some automatic rules set up in place, which basically look at the IP addresses of the components which I got from the configuration file, and they immediately map down the touch points that are running. For example, this particular Nginx server is running a TLS endpoint, and till now, actually, you're not reached to the cryptographic level. What you know is basically the kind of protocols that this web server is supporting. And the final, basically, finish up would be to actually go to the cryptographic scans, which is where I create another scan. And I start with a very simple method, which is actively probing your instances, your web servers, to check what kind of cryptographic configuration they support. There are other methods. You can actually rely on the internal CLM. You can upload the logs there, or it could automatically connect as well. But for this, I will just quickly upload the active probe snapshot I have as well, right? So once I do that, there were again around 7 probes that we did for each touch point. Here, select this, and I can quickly see that, okay, yeah, we have gotten at least some sort of start with the cryptographic inventory we have now, right? There is still a lot of missing information that you cannot get by directly pinging the touch points, but you can supplement that by other scan methods as well. And now let me quickly get to the profile method, right? Like, why did we do all this effort? Because eventually you want some reward, and your reward is basically, now if I quickly go to my inventory, I can just do one simple click here and evaluate this service against a TLS profile. And you immediately get a quick report of what all the components in this service, what kind of violations are they creating. And they all depend on the kind of profile you have set up for each touch point. That this touch point is supposed to have advanced policy, and it clearly finds out that these certificate algorithms, in advanced, you're not supposed to use RSA 2048. Permitted one was 4096, so you're only supposed to use that, and gets flagged out. At the same time, it also flags out certain information that you have not inventoried, which is again an indication towards that something you need to inventory, maybe through other discovery methods, to complete this verdict. And that's again gives you an indication of what you need to do in better discovery methods. And I think that's yeah, more or less what I had to talk about. And the final point was about that because these profiles are something that you can continuously update, you can parameterize. So as standards or organization priorities change, what you have to do is basically update the profile and rerun the scans and rerun the evaluation. And you again get an assessment of where you stand right now, right? And what you need to change and what you need to collect more to achieve that compliance level. And I think that's all from my side. Thank you.
Yeah, so maybe just to conclude, what I would maybe highlight here is that whatever activity was done in terms of running the scans, setting the protection profiles, were actually done with regards to the sandbox environment that Arav actually described. It's still sort of developing. We are actually having more components like HSMs, having Venafi CA, CLMs, having like AWS load balancers and AWS database servers and so on. So we're adding more vendor support in the sandbox environment, so it's more diverse. But the plan is to actually give this sandbox environment for you to actually try out, and whatever activity you want to do on quantum state migration, understanding how to set the protection profile, how to run the scans, you can actually do it on the sandbox environment, and then you can understand what it does, what outputs it generate, and then can go back to your production environment. So the plan is to sort of deliver the sandbox, and you can not just run our tools, but you can also run other third-party tools. You can develop your own scripts to run on that environment. So yeah, if you're interested, we'll be happy to engage with you like post after the session. So that's it. So I do hope we were able to do a bit more deep dive into how the planning phase for quantum state migration would look like. So yeah, I think I'll conclude at this point. So thank you very much for your patience. Thank you.